So in this video, we're going to talk about the law of sines. So the law of sines says for any triangle, so it doesn't actually have to be a right triangle. So here's a generic triangle. We have angles A, B, and C, and we label the sides little a, little b, little c. And so the law of sines says that for any triangle, the following ratios hold. So for any triangle, the sine of A over little a is equal to the sine of big B over little b, and is equal to the sine of big C over little c. So we're going to do some problems here. So we want to solve the triangles. So solve the triangles. And that just means we need to find all the missing sides and parts. So my first triangle here is going to say that A is, not A, sorry about that, that capital B is equal to 25 degrees, capital C is equal to 106 degrees, and little a is equal to 7. So if I draw some generic triangle, and we label it A, B, C, obviously it's not drawn to scale here, but we're saying little a, so the side across from big A is 7. We're saying B is 25 degrees, C is 106 degrees, so you can tell for sure this is not drawn to scale. So we want to find the other pieces. So the first thing to find would be angle A. So angle A is going to be 180 degrees minus the 25 degrees minus the 106 degrees. So all the other degrees in the triangle. So that ends up being 49 degrees. So A here is 49 degrees. And now that allows me to set up to use the law of sines. If you notice, I happen to have 49 degrees and the 7. So I can say that the sine of 49 degrees over 7, and if we were trying to find little b, is going to have to be equal to the sine of 25 degrees over little b. So at this point I could cross multiply. So b sine 49 degrees is equal to 7 sine of 25 degrees. Divide both sides by the sine of 49 degrees. So little b is going to be 7 sine of 25 degrees divided by the sine of 49 degrees. And if I round, I should have really said round to the nearest tenth on these. So round to the nearest tenth. Oops. Should probably write that out in words. Tenth. So it's going to be 3.9. And then I can do the same thing to find C. So the sine, again, of 49 degrees over 7 is going to be equal to the sine of 106 degrees over C. I picked the sine of 49 over 7 again because I want to stick with pieces that I haven't rounded. So if you tried to use the sine of 25 over the 3.9, we rounded that 3.9, so we want to try to avoid, if at all possible, using it in our calculation. So we're going to end up with C sine 49 degrees equals 7 sine 106 degrees. If I cross multiply, divide both sides by the sine of 49 degrees. And so C is going to be 7 sine 106 degrees divided by the sine of 49 degrees, which is going to end up being approximately 8.9 when I round it. So we'll try one more here in this first group of them. So B, A is equal to 55 degrees, C is equal to 48 degrees, and little c is equal to 20. So again, I have my generic triangle. It's not drawn to scale. So I have A, B, and C. So I know A is 55 degrees, C is 48 degrees, and I know little c is 20. And right away I can figure out B. So again, all the angles in the triangle add up to 180. So B is going to be 180 minus 55 degrees minus 48 degrees. So in this case, that's going to turn out to be 77 degrees. So now I know little b. So this here is 77 degrees. And then, or big B. If I want to find little b, we're just going to do the sine of 77 degrees over little b equals, so this time we happen to have the C pair here. So we're going to have the sine of 48 degrees over 20. So sine of 48 degrees over 20. So 20 sine 77 degrees equals B sine 48 degrees. Divide both sides by the sine of 48 degrees. And if you punch that into your calculator, B ends up being approximately, I should have made this an approximate. Oops, we'll just rewrite it all. So B is approximately 26.2. And then we're going to do a similar thing to find little a. So the sine of 55 degrees over little a is going to be equal to the sine of 48 degrees over 20. So cross multiply 20 sine 55 degrees equals a sine 48 degrees. Divide both sides by the sine of 48 degrees. The sines of 48 would cancel, and so a in this case is going to be approximately 22.0. So the law of sines is pretty nice, especially when you're given two of the angles. So all of the problems in this section, they give you two of the angles, and that makes it a little bit easier to use the law of sines.